Level 5.6 is logarithmic and exponential equations. And this is just going back and forth between logs or exponentials in order to solve certain equations. And this is our last bit of algebra before we get into the story problems, which are the last two sections. So just a quick remember how to change to exponential, an exponential to a logarithm. Just remember your bay. Remember, we have our base, answer, exponent. So base, answer, exponent would be log base b of a equals our exponent. That's our bay, BAE. So if we are solving, if we have two logs that have the same base, that means the insides have to be equal, provided that the base is not equal to 1. Okay, so what does this mean? Get the same base on either side, then set insides equal to each other. Okay, so that's not that bad. That's kind of like what we did before with exponentials, where we got the same base, so we set the exponents equal to each other. Same concept. So here we have 2 log base 5 of x equals log base 5 of 9. So the exponent goes up because that's one of our properties. So log base 5 of x squared equals log base 5 of 9. So then the insides should be equal. So x squared equals 9. Square root, x equals, remember when we take the square root of a variable, plus or minus 3. Now the thing about logs is, remember way back at the beginning, logs can't be negative. So that negative doesn't work, and our answer is only x equals 3. Because when we go back to the original, even though we have this x squared, it still would be 2 log base 5 of negative 3, which is not what we want. Okay? So our answer is only x equals 3. Next up, well, use our properties of logs instead of getting them all on the same side, because this doesn't have a log. So addition becomes multiplication. Log base 5, x plus 6 times x plus 2 equals 1. And now we get to use our base answer exponent. So 5 to the first equals x, and I'm just going to multiply this out, x squared plus 6 plus 2 is 8 plus 12, 6 times 2. So now we're just going to solve. We're going to subtract 5, and we get 0 equals x squared plus 8x, and then 12 minus 5 is 7. So this factors into x plus 7, x plus 1. So x is equal to negative 7, and x is equal to negative 1. Now, what we just said, logs can't be negative. So we have to check the original to see if either of these fail. So if I plug in negative 7 here, I get a negative 7 plus 6, which is a negative 1. And I also get a negative 7 plus 2, which is a negative 5. Not good. So negative 7 doesn't work. If I plug in negative 1, negative 1 plus 6 is 5. Negative 1 plus 2 is 1. That works. So my only solution is x equals negative 1. Make sure you check your answers. Next up. Okay, we got logs on either side. So I'm going to combine these first. I have ln of x times x minus 4 equals the ln of x plus 6. Now that I have two logs equal to same base, so then the insides have to be equal. So I have x squared minus 4x equals x plus 6. Now it's just algebra. Get the x's on the same side. Minus 5x minus 6 equals 0. And then factor this. So this factors into x minus 6, x plus 1 equals 0. So x equals 6, x equals negative 1. Now just to check, if I plug in 6, works. So this one works. If I plug in negative 1, it fails for the first one. So it's no good. No bueno. So Again, by checking our answers, we can't have a negative log, so that gives us just our one solution. All right, flip it over. We got a couple more problems to go. So the flip of this is solving exponential equations. So how do you get to solve for x here? Well, we know that if we take the log of both sides, we can get the answer. So what we're going to do is we're going to take the natural log or log of both sides. Whatever you do to one side, you do to the other. And by doing this, we are able to move x in front. So x ln of 2 equals ln of 5. And if this looks like the change of base formula, it is. So we would get x equals ln of 5 divided by ln of 2, which is some number, and we just leave it like this. Now, if we just wrote out our bay and we said log base 2 of 5 equals x, this would be the same thing. Here, now, on a test, I would either ask you, give this answer as an exponent or a decimal, or leave it as simplified like this. Either way, you get the same thing. So how about here? Can we do the same thing? For b, well, first, in order to get the x by itself, I need to divide by 8. So first things first, get the exponent or exponential function by itself. Then we're going to take the log of both sides. So we have x ln of 3 equals ln of 5/8. And then we're going to divide by 3, so x equals ln 5/8 over ln of 3, which again is a decimal. Right now, we're good enough to just leave our answer like that. So, can we use the same type of process when we don't have like bases? Absolutely. This is what we're going to do. So, obviously, there's no way we can get 5 and 3 to be the same number. So what we're going to do is take the log of both sides. So the ln 5 to the x minus 2 equals the ln of 3 to the 3x plus 2. What that allows us to do is slide these forward. So that's x minus 2 ln of 5, which is just a number, equals 3x plus 2 ln of 3. Now this may look like gibberish right now, but we can, all this is just doing algebra. So we're going to distribute this 5. We get x ln of 5 minus 2 ln of 5 equals 3x ln of 3 plus 2 ln of 3. Now similarly, when we were talking about inverses, get the x's on the same side, get the numbers on the other. So I have x ln of 5, subtract this, minus 3x ln of 3 equals 2 ln of 3, add the 2 to the other side, 2 ln 5. And the last little bit, factor out an x. So this is ln of 5 minus 3 ln of 3 equals this whole thing. And then we divide by this quantity. So we get x equals 2 ln 3 plus 2 ln 5 over ln 5 minus 3 ln 3. Now, it looks super complicated, but it's not. All of these are just numbers, and we're solving for x. So, similar principle. Obviously, we can't get these to be the same base, so we're going to take the natural log of both sides. So ln, which means we have x plus 1 in front, put parentheses around there. ln of 2 equals 1 minus 2x ln 5. So step 1, then we're going to distribute. So we have x ln of 2 plus another copy of ln of 2 equals ln of 5 minus 2x ln of 5. Get the x's on the same side, numbers on the other side. So we have x ln of 2 plus 2x ln 5 equals ln 5 minus ln 2. Factor out an x. And last step, divide by this quantity. So x equals ln 5 minus ln 2 over ln 2 plus 2 ln 5. And that is our answer. So the last one, which are my favorite ones, because this is algebra in disguise. You can factor something like this. It looks like a quadratic. We're going to treat it like a quadratic. 4 to the x is the same thing as 2 to the 2x minus 2 to the x minus 12, because 4 is 2 squared. So really this is my x squared term minus x. Let's just pretend for a second that I said u was 2x, okay? So we're going to do this something called u substitution. This is u squared minus u minus 12 equals 0. That you know how to factor. This is just u minus 4, u plus 3. So then we either have u is equal to 4 or u is equal to negative 3. Well, this is just 2. Now we go back to what is u? U to the 2x equals 4, or 2 to the x equals negative 3. Well, there's no number that you can make an exponent negative, so this doesn't work. And 2 to some power equals 4, so x equals 2. These are super fun because, surprisingly, algebra pops up into exponential functions. So all of the things that we learned since freshman year work here. So that takes care of solving exponential and logarithmic equations. We got these problems down here. The last bit of this chapter is story problems. So be prepared.